All right, 8.2, we've got adding and subtracting rational expressions. So we've done simplifying rational expressions, multiplying and dividing. Now we're going to look at adding and subtracting them. And first, we're going to start off with a like base. Those examples are pretty easy. Then we'll look at unlike bases. So what you're going to do here is rewrite the problem using a common denominator, which the like base is already going to have it. But then you're going to combine the numerator, keep the common denominator, and simplify the remaining expression. So let's look at numero uno. We've got 13a over 4a squared plus 5a over 4a squared. We've got the same denominator. So all we've got to do is add this just like any other fraction with a common denominator with the same denominator. We just add across the top and keep the bottom. So 13a plus 5a would be 18a over 4a squared. Now we have to simplify this, and we would just do that with our rules for exponents. So we've got 18 divided by 4 here. That's going to reduce to 9 over 2. Then we've got a over a squared, which is the same thing as saying a to the first divided by a to the second. So we subtract our exponents when we divide, and that's going to give us an a, but it will go on the bottom because a, well, if you want to see the long version, so a to the first over a squared is going to give us a to the -1, and then we would have to put that on the bottom of a fraction. Or the way that I always just look at it is whatever number is larger. So if it's larger on the bottom, it's going to stay on the bottom. And if it's larger on the top, it's going to stay on the top your variable. So we've got 9 over 2a as our final answer. Now I'll show you another one. Sometimes these can just get a little complicated, but not too bad. So if we look at number 3, we've got y squared plus 8y over y squared minus 9 plus 2y plus 21 over y squared minus 9. So we're still adding here, which these don't really change when adding or subtracting with the common base, but we're adding here. We've got the same denominator, so that means all we've got to do is add the top and then keep the same denominator. So when we add the top, we'll get, let's see, y squared. We'll take positive 8y plus 2y, which will give us plus 10y. And actually, let me move this to the bottom. So we'll get y squared plus 10y plus 21, because 21 doesn't have anything on this side to add with it, doesn't have a common alike term. So then we're going to have y squared minus 9 on the bottom of our fraction. Now this is where you just have to get really good at factoring. And so to simplify this, we're going to have to factor the top, factor the bottom, and then we'll cross everything out that we have to cross out. So if we factor the top, we'll get y plus 7 times y plus 3, because 7 times 3 will give us 21. 7 plus 3 will give us 10. And then the bottom is actually a difference of squares. So we only have 2 terms, and a subtraction sign is in the middle. And we can use a difference of squares on this. You'll just have to recognize and get really good at seeing those. I've seen a lot of you are pretty good at them, but if you struggle with these, you'll just have to get better at them and practice them. So let's see. When we're doing difference of squares, we square the first term minus the square root of the second term. So we'll have y minus 3, and then we just have to double that except with a plus sign. So now we can look at what we have on the top and the bottom to cancel out. And we got a y plus 3 on the bottom and top, so those will cancel out. So we'll be left with y plus 7 over y minus 3. And that would be your answer, because we can't factor this anymore. We can't cross anything out, so we're done. All right, so that's when we have a like base, or we already have the denominator as the same thing. Now we're going to look at when they're not the same. And this is no different than when you have a fraction like 2 over 3 plus, 4 over 5. Whenever we have this setup, we've got to go and create a common denominator. That's the same thing you're going to do for these problems. It's just sometimes they're a little bit trickier, but they're not too bad. So if we look at 7, we've got 15 over 2x minus 16 over 3x. So we need to break down 2x, 3x, and say what is the greatest common denominator between those two. And it's pretty simple because they both have an x, so we know that it's going to have an x. As long as they both got a variable, we don't have to make it x squared or anything like that. They just both will have that variable. And then, let's see, the greatest common denominator of 2 and 3 would be what? 6. So our greatest common denominator is going to be 6x. Now, here's how you decide. It's kind of the same process as when we did like our simple fractions. When deciding what to do next, we're going to look at each side of our minus or plus sign and just ask yourself, okay, when I look at 2x, what does 2x need to get me from 2x to 6x? And that would just be multiplying by 3. So that's what you'll take and multiply to the top of your fraction. So we'll have 3 times 15 on the top of our fraction. Then we'll do the same thing with the right side denominator. So the right side of our subtraction sign, our denominator is 3x. You need to say, all right, how could I get from 3x to 6x? And that would just be multiplying by 2. So we're going to multiply this side by 2. So we'll have 3 times 15, which is 45, minus, we'll keep our minus sign, 2 times 16, which is what, 32? And then we'll subtract those. So we would say 45 minus 32 is 13. Would keep 6x on the bottom. So we'd get 13 over 6x. So sometimes people get a little confused on those. But I think if you just approach it with asking yourself, okay, what do I need on each side? I think you'll be okay. Let's look. Let's see. Which one do I want to do next? I think I'm going to do a little bit of a harder one. So we're going to go, number 8's a good one too. But I'm going to try to focus more on the harder ones. On number 8, when deciding what your common denominator would be, they both need they'll both need a variable that is a squared, since we have our larger one with a squared. And then since we have an a on the right, we would need it overall. So our common denominator here would be 8a squared. And when deciding deciding what to do next, just look at each side of denominator, or each side of the subtraction sign denominator, and say, how do I get from a squared to 8a squared? That would be multiplied by 8. And then how do I get from 8a to 8a squared? That would be multiplied by a. So that's what you would do for that portion. So I'll just show you that, but we'll probably go through an example like that in class. I want to focus on another harder example. So let's look at number 9. So on number 9, sometimes it's going to be best to factor your denominator, because that's going to tell you what you need for your when you're creating your greatest common denominator, or your I guess it would be the least common denominator. But either way, so as long as you've got a common denominator, you'll be good. All right, so we've got k squared plus 16 minus 4 over, or k squared plus 16 divided by 5k minus 10 minus 4 over k minus 2. So we don't have the same denominator here. We need a common denominator. So here's what you'll need to do first. Let's factor this 5k minus 10, because if we factor that, you'll notice that all we're really going to do is pull out a 5, and we'll be left with 5 minus 2, or 5 times k minus 2 on the bottom of our fraction. And the only difference here between this side and this side here is this 5. So all we really got to do for this one is use because the left side is actually our common denominator. So if we just use that left side as our common denominator, the only thing we've got to add in here is to the left side. We need a times 5 over here. So we need to multiply 5 by the top of our fraction, and then we'll be good to go. So we'll bring down k squared plus 16 minus 4 times 5 is 20. let's see, that would reduce down to, now all we've got to do is reduce this, or simplify this. So now we would have k squared, because there's nothing to add that to on the left. Let's see, 16 minus 20 would be minus 4 over k, it would be 5 times k minus 2. So then we just have to simplify this further. And like I said, you're going to have to notice the setup of a variable squared minus a number is probably always going to be an indication of difference of squares. And when we do that, we're taking the square root of each of these with a minus sign in between. So we'll have k minus 2. And then we double it with a plus sign. So k minus 2, k plus 2 would be how we factor that. Then we'll be left with 5 times k minus 2 on the bottom. And now you can see we have a k minus 2 on top and a k minus 2 on bottom. So we're actually going to be left with k plus 2 over 5. So the important part here is to note how to find this beginning common denominator. And the cool thing was, when we factored this left side denominator out, that is actually what our common denominator is going to be. Because we already have the k minus 2 portion, we just needed the 5 for our right side denominator here. So all we had to do was multiply the top number, which was 4, by 5, and we were good to go. So some of these seem like they would be complicated, but they're actually not that bad. And now I'm going to show you another one that's probably the most complex one, but I still don't think it's that bad, because it's the same type of process as number 9. So let's look at 11. So on 11, we've got x squared minus 5 divided by x squared plus 5x plus 6 plus 1 over x plus 2. So with our denominators, we need a common factor, but watch what happens when we factor out x squared plus 5x plus 6. We would actually end up with, let's see, x, well, I guess it'd be x plus 2 and x plus 3. Yeah. Because positive 3 times positive 2 is 6, and positive 2 plus positive 3 is 5. So we're good to go. But if you notice, if we want a common denominator here, we've already got this x squared over here for our denominator. All we've got to do now is account for this x plus 3 on this right side, and that just means we're going to take x plus 3 and multiply it by the top portion. So our common denominator is actually still just x plus 2 and x plus 3. And so our left side here, we'll just pull down x squared minus 5 plus, let's see, x squared, or x plus 3 times 1 is just x plus 3. So now we just have to combine everything. Then we may have to go back and factor everything out again. But now we've got our setup that we need. So now this is just combining like terms on the top. So x squared, let's see, plus x minus 2, because negative 5 plus 3, those were the only actual common or like terms we had. The bottom's already factored for us. X squared plus, or x plus 2 plus x plus 3, or x plus 2 times x plus 3. I can't talk. Now I just need to factor this top portion. This is just a simplifying expressions. So I need to factor out that top portion, and then I'll be good to go. So if I factor out that top part, I'll get x, let's see, x plus 2, x minus 1 is what I would need for that. So then we'd have x plus 2, x plus 3. Now we've got some stuff we can cross out. So we've got an x plus 2 on top and on bottom, so those are gone. X minus 1, x plus 3 is going to be on top, and that would be our answer, because we can't break that down anymore. So, like I said, when you have a denominator and it's not factored, go ahead and factor it, because we'll probably be able to use that as our common denominator, or we may be able to use pieces of that, but it makes life a lot easier on yourself when we do that, because we can say, okay, we've already got this x plus 2 portion sorted on the right side. We just need to account for x plus 3 on this side for our denominator. So we're going to multiply that portion by the top of our fraction, and we'll be good to go. And that's really all you need to know for 8.2. So be sure to look over these. And then, like I said, we'll work some problems in class over these. And then we'll go over some of the homework.